when you're comparing the alternatives, well, maybe I actually don't want to record this because whoever's watching it the next semester could just watch the solution. Because I'm sometimes interested to know, like, what am I working with as an average? It's not like I remember on an individual basis, but I'll calculate the average for the class. And almost every time I do that, the ACT score average for the class is like 24. That's the average ACT of the students in our program, but I'm betting this class is a little bit higher than that because you guys are doing really well so far. And especially in contrast to the group I had last year, they really struggled. So I'm pleased that it's going to go well for us this semester. I have high hopes and high expectations. All right, so let's look at some announcements. Your next homework assignment is due on Monday. No rest for the weary. We had quiz 2 today, and we're going to continue talking about cost estimating. We're going to do a couple of activities on the computer, so I've opened up the tablet part. We're going to do in-class exercise number 5, which is about indexing. Any questions from yesterday's lecture before we dig into the new stuff? Any announcement or schedule issues you want to ask about?
On the first in-class thing from yesterday, are we going to go over, I guess we haven't even turned it in, so we'll probably go over that.
Yeah.
Okay.
Yeah.
Wait for
All right, yeah, so in fact, let's do that now. Why don't you pop out your in-class exercises, and if you finished it, I'm going to make a note of that. And if not, I can provide a little bit of guidance for you. We can take a few minutes. In-class exercise 4 is where you are generating the index. Similar to the example that was in the lecture. Did you have a specific question on that one that maybe I could address generally that everyone would maybe also be wondering?
Because we were talking about it before class, and I want to be sure that I'm right or wrong. Because in the book it says one thing, but on D, estimate the itemized cost of labor, everything in 2008 using the top-down approach or top-down approach. You would ignore the cost that you just came up with. You wouldn't take the 30%, 20%, 50% of C, would you? You would.
You're saying
you'd have to take the 650,000 that you know from 2004 as your base and add inflation in. Like that's what the example in the book said. That's I didn't know if that was the correct way to do it. Or
I see what you're saying. So you're saying since it's top down, you wouldn't break it into the subcomponents of labor, materials, and equipment.
You wouldn't even use the indexing way of.
Top down is just using the whole information.
Yeah, it's using the whole project and then extrapolating it based on the whole project. Yeah, what I had actually intended was for you to break down it into labor, material, and equipment. So I should probably rewrite that to make it more clear. Let me show you the calculations that I've got. Let me get the in-class exercise from you. I'll collect those and we'll just sort of check it off and glance at it as you're working on another example today. But before I collect it, if you want to spend a few minutes correcting or asking about anything, we can do that. So these in-class exercises are basically, you know, you tried it, you gave it your best effort, you get 2 out of 2 points. You didn't do it, it's 0 out of 2 points, and you did it, but sort of half-hearted, and that would be 1 out of 2 points.
Right, well, that's exactly like what I was talking about with D. Because you took the estimate you got from the indexing weight,
right?
Which, from what I understand from the book, which you would, from a top-down approach, you wouldn't use that method. You would basically go off of something you did before, which is the only thing it says in the original 650,000. And like in the book, the question was like, if you were to go to school, you'd have like each year, and then it added 6% increase to it.
So you solved this a different way?
Yeah.
Why don't you show me the different way that you did?
Okay, I took the 650,000 that's known from 2004, and I multiplied it by the percentage of the the labor,
Mhm.
which was, you know, by
30,
30%,
20,
50%, which came out to give me a 195,000, I gave it 195,000, and then I multiplied that by 7% increase.
Where did you get 7%?
Well, because in the book it used 6% for that one college track.
As inflation?
As inflation, but I was kind of, and then I kind of just took the inflation number that was the actual inflation that we got from the indexing, and I figured I better not use the same exact one, and just kind of.
So you calculated on average how are prices changing over time from year to year, right?
Well, I just went from 2004
Okay.
to 2008, just using the baseline of 7% inflation.
All right. So you use the ratio of the indexes then? I mean,
Well,
because that's essentially what you're doing when you're calculating
Yeah,
inflation.
well, I mean, I did that to just get an idea of what I should pick for an inflation just for that problem, but, I mean.
So what was the final answer?
I got total, at 7% inflation, I got 695,500 as being the cost.
Did you get the itemized costs? Because that's what it's asking is, what are the costs of each of the items?
Well, using.
From the top-down approach. The top-down approach is that you've got an overall cost of the project.
I used, no, I didn't get the same answers because I used what was known from the original, from 2000, the only thing I had to go from.
I'll take a look at what you did, and you may have an argument that way, but this is what I had in mind.
Okay, well, that's why I didn't, I mean, we all had this, they went with y'all's, basically what you have, and I was going with the other.
Okay, any other questions? All right, so why don't you slide those in-class exercises over, and I'm going to take a look at them while you're working on another example from today's material. I struggle with what to call it because it's not really an in-class exercise when it's a WIMBA lecture, but we'll stick with that anyway. Everybody got a copy of the notes?
And then the question, it was on page 69 was the examples.
Okay. So what's this a picture of? Anybody know?
Sweatshop?
Sweatshop, absolutely. What's that?
Let's shut the camera.
I think it's going. Thank you. Yeah, this is a sweatshop, and this is over in India. And these people, if you've ever seen video of clothes being made, it's incredible how fast they can do it. You know, I've never really sewed anything before, but if I tried, I would imagine that like doing the pants, I'd be going so slow because I'd be worried about going outside the lines or something. But if you've ever seen video of these people, they sew a pair of pants in just a minute, 2 minutes. They're incredibly fast. And so one of the factors I wanted to mention today is the learning curve and the improvement in ability that a business can count on when a task gets done a lot of times. And so one of the things that engineering economy is about is understanding how to generate models. A model is a representation, a numerical or a physical representation of reality. If you think about a model car, that model car is meant to represent a full-size car. Or a model who's walking down the runway and displaying clothes is supposed to be a representation of what we will look like if we buy those expensive clothes. And so, in scientific and economic terms, a model describes how things are going to be. And what this model that's shown on the screen there, the equation, is a model of how much quicker someone can be at a task when they experience a learning curve, when they get better over time with the repetitive production of the task. And so with a logarithmic improvement, it's not linear. It's not like when you do twice as many, you get twice as good at something. Over time, there are diminishing returns of how much additional learning. At the beginning, the improvement is really big, and there are huge gains in efficiency at the beginning of an industrial process. But towards the end, over time, the additional gains and improvement begin to taper off. And so if you look at the equation and what sort of factors it takes into account, what we're going to be looking for is input resources that go into making output unit U. And so it can be time, that's the input resource, and output unit U is what number of however we've made. The first one that we've made versus the 20th one that we've made. And And so over time, u will increase from 1 to whatever n, however many of them that we've made. There's also a, like I said, this is a logarithmic model where we're keeping track of the learning curve slope parameter. We have to at first know, calibrate the model based on, we will have measured the improvement in time between 2 points so that we can find s, and then once we know s, we can use the model into the future as far as we want to project. And so as an example of that, let's consider if you are working in one of those sweatshops and on your first day, it takes you 85 minutes to sew that first pair of pants. And then the second pair of pants you make, it takes 76.5 minutes. And by the time you do your fourth pair of pants, it's 68.85 minutes. And so with that data that we have, a few measurements, what we can do is find the parameters of the model and then use the model to predict the rest of our performance. How much time it will take to do the 10th pair of pants, and then the cumulative amount of time that it will take. All right, so we want to first know the learning curve exponent. So we can find that. We can find out what s is, because 76.5 is equal to s times 85. It's the improvement over time between the first and the second pair of pants. In other words, s is 76.5 by 85, 0.90. It took us 90% as long to make the second pair of pants as it didn't take the first pair of pants. So ultimately, what we're trying to find is for the 10th pair of pants, u equals 10, we can calculate the learning curve exponent for that. N will be the log of 0.9 divided by the log of 2. And so n will be negative 0.152. And k, the number of input resources to produce the first unit, k was 85 minutes. The first time, our baseline was 85 minutes to make that first pair of pants. And so, on the 10th pair of pants, it's going to take 85 minutes times 10 to the negative 0.152. So that will be 85 minutes times 0.7047. That's 59.9 minutes. So it also asks the total amount of time to take for 10 total pairs of pants. So for the first, second, third, fourth, fifth, we know already the first one was 85. The second was 76.5. The fourth, 68.85. And now we've calculated that it's 59.9. All right, why don't you find out the 7th pair of pants, and then we'll talk about an automated way to solve that whole thing so that we wouldn't need to do them all by hand. For the 7th pair of pants, how long would it take? Do that by hand. so in this, what we're doing is we're looking at really how many generations it's been since we started doing pants. And 1 to 2, 2 to 4, 4 to 8, when we've been making twice as many pants is how it works. What you'll see is it was the fourth pair of pants that took us to 68.85. And that's an important clue, that if you multiply 85 by 0.9, you get 76.5. And then when you've done twice as many pants again, when you go from 2 to 4, that's when you're, again, only taking 90% as much time. So 76.5 times 0.9, now at 4, you're doing twice as many as you had in the previous iteration. And between 4 and 8, it's going to be another 90% factor. And so 90%, 68.85. 68.85 times 0.9. So here it would be 61.965. So what's the range of answers you got for 7? 4. A real easy way to do it is on Excel by putting together a curve. If we know that here on the 4th unit it is equals 0.9 times equals 0.9 times there, and then 8 is 0.9 here. We can make a graph. Here's our x data. I don't think those spaces will be a problem. Hopefully it'll just yeah, I don't actually think we probably do need to leave the gap. There we go. So you can see over time how the improvement is doing and find out from that at any point how many pairs of pants, the amount of time it's going to take to make them. All right, so moving on to the unit technique is a way of constructing a, did you have a question?
Yeah, on that last problem, would you use the same numbers to figure that out?
What do you mean?
Like, instead of, like where you said Z10 equals 85 minutes, instead of putting 10, would you just put a 7 there and then solve? Would that give you the right answer for something?
You could also use that, yeah. If you're doing, you mean like the 7th unit or the 8th unit?
Right. What you're trying to, you said it's all for the 7th,
yeah. Exactly. Okay, the unit technique is a way of estimating costs by finding out for every component of a process the price or the revenue that can be generated from the component that goes into it. And sometimes costs are estimated based on, for an electric power plant, maybe they look at the kilowatt hours of capacity that it can generate, or if it is an airline, they look at the amount of revenue they generate for every mile of flying that they do. And so the unit technique can be used for anything that the components add up and you're either having costs or revenue that's based on some unit of measure. And here's just a list of lots of possibilities. Temperature loss per 1,000 feet of steam pipe, and so that you could scale up once you have data that allows you to characterize any one of these things, you could scale up to how much you expect to have on the project you're constructing. The factor technique is a way of applying a work breakdown structure, and you know each of the components that goes into a project, and then you use the unit technique to come up with the total cost. In other words, it's like a multivariable linear regression, the factor technique. So here's an example of the factor technique down at Pullman Plaza. They charge rents based on the square feet that are being used from a business. And so different types of businesses and their location may have an impact on the rent that's charged. If it's down on the first floor, maybe they're charging a higher amount of rent than if it's up in a more obscure location. And that's the case here where for restaurant space, they're charging a $23 per square foot cost, and for a clothing store that's maybe in a different location that's less prominent, they charge a lower rent rate. Utilization, if you were trying to find out how much rent you could expect, you'd have to know the occupancy, not only at any one time how many of them are vacant, but how long the vacancy is going to be during the year. And so this percent utilization is just how much of the actual office space or the restaurant space that's available is being utilized. And so you could generate an estimate of the revenue in Pullman Plaza by this technique. And I'd like you to give that a try. Find out in total what is the revenue that can be expected from not only the rents, but also the parking spaces and billboard advertising opportunity, the annual revenue that would be expected for this location. everybody get this 446, 130? Any questions? That's a relatively simple example based on the unit factor being square feet of space that can be leased.
Well, how are you getting the parking in the building?
Because it's $22 per month, and so I'm multiplying it by 12 months per year. When we go for the annual rents. We're going to be working an in-class exercise, the first part of which may be familiar to those of you who've already done Engineering 111. I think Dr. Pearson has you apply this factor technique to estimate the cost of launching a spacecraft, like launching a satellite. Do you remember that one? Well, maybe he doesn't do it anymore. I'm glad that you get a chance to find a regression model. Parametric models, you're probably familiar with from high school, where you learned how to find the best fit line through a set of data. And regression analysis develops equations based on past data, and then you can, with that empirical relationship between one input variable and an output variable, use the equation to estimate future costs or future performance. It's as simple as taking XY data and graphing it, and then creating a best fit line. And we're going to do that in class today. If you're already an Excel power user, you probably already know how to insert a best fit line. This is a linear curve. You can have it insert different types of curves. You can have it do an exponential function that it'll create, or any other variety of power functions. If you haven't used Excel before, what you do is you create a graph, which is easy enough. Then you right-click on one of the data points, and it'll bring up a context-specific menu that gives you the option to add a best fit line. And what we've turned on in this case is display equation, and for it to calculate the R squared. And Elman, do you know what the R squared is a measurement of?
Maybe the average?
No, it's not the average. What, do you know what it is, Mark? R squared is a measure of how good the curve fits the data. And so if the data was further away from the line, the R squared would be worse than it is right now. The closer it is to 1, if it's exactly 1, that means that the data points are exactly on the line. And so sometimes there will be outliers that may defy the general trend, and sometimes you'll have data that's very well described by the relationship. So for example, if we created a chart, I told you earlier that I sometimes will look up the ACT score of the class just so I can calculate an average. And I was surprised that it's consistently an average of 24 for the ACT score, but what if we wanted to take ACT score and predict college GPA? Would you expect that it would be 100% linear? Would you expect that there is an invariant relationship between ACT and GPA?
Absolutely not.
Why not? You seem pretty strongly convinced.
Yeah, because I have a higher ACT score than 24, and I definitely don't have that good of a GPA.
So there are other factors that determine the relationship. What are some of the other factors besides just ACT score?
Difficulty of classes.
Okay, absolutely. Yeah, class difficulty. If you were majoring in communications versus majoring in computer science or engineering, that's going to be a factor that ACT versus college GPA doesn't take into account. What else?
Maturity.
All right, maturity.
I guess age would be okay also.
Huh?
Age.
Age.
Time.
What do you mean time?
Whether or not you have a second job or anything.
Okay. Other responsibilities?
Yeah.
Laziness.
Yeah. That's a big one.
All right, laziness. Or motivation.
Lack of
All right, so sometimes regression models will just have a single parameter, like this does. There are statistical tools where you could measure all of these and come up with an equation where if y was GPA, college GPA, it would have x referring to ACT score. Then maybe it would be plus a number times some other factor. You know, like if it's male versus female. I've created a regression model before that predicted, it predicted college GPA based on high school GPA, male versus female, or some of the other factors, nationality, and for example, if you were a male, you had to subtract a couple of points on the average predicted college GPA. Female, at this particular university where I created the equation, it was plus a couple of points. And so that was a multivariable regression equation. What we're going to be doing in the in-class exercise today is generating just a single variable regression equation and then seeing how well does this one parameter that we're picking to describe the output behavior seem to fit the data. All right. Any questions about what parametric methods are used for? If you want to do it manually, and I guess we probably should do it manually once so that we appreciate how easily Excel calculates R squared for us, there is a way that we can calculate a best fit line ourselves. If we started off with weight and cost relationship, we can use, let's see, the formula we would use in order to find the slope and intercept of the best fit line is shown here, and the way that we have to set it up is we have I, which is the number, the data point number, x of I, y for that, xi squared, and then xi y I. So we construct a table where we've got 1, 2, 3, 4, 5, 6 data points, and 400, 278, 530, 750, 900, 30. What I'd like you to do is calculate x squared and xi yi, so x squared and then x times y, and what we're going to do at the bottom is sum them up. So we'll have the sum of this, we'll have the sum of that, and that, and that, and then we use those. That's what these are. We'll have this n, which is the number of units we've got in input data, 6, times the sum of xi, yi, which will be the sum of all of these, minus the sum of just the x's, minus the sum of the y's, divided by, you get the idea. So that you can appreciate how lucky you are to have Excel available to you, just this once in your life, you're going to have to calculate the regression parameters by hand. You've done it before?
No, I'm just talking about using calculus to solve.
That would be n. It's the n times n minus divided by n. No. Actually,
I'll find the sum of these two. Let's see. 49, 10, 35, 29. You do the rest. question about something?
I'm done.
Got it?
It's all about.
Did you do it somehow specially on your calculator?
I could have, but I didn't.
You did. You got a pretty powerful looking calculator. Not as powerful as an HP, but.
I think I'm more of an HP out of water.
No.
TI inspired.
We'll see. We'll have a battle of the calculators later.
Yeah, I don't think, the problem is I don't know how to use mine as well as.
Oh, okay.
That's what my downfall is.
You don't carry the manual around?
It doesn't come with a manual. It's got a whole program you can plug it into.
Yeah.
Lots of YouTube videos. No, I can't watch YouTube on. If I had the wireless adapter, I could. But I don't really think the wireless adapter.
Yes, Charlie.
It's a 1 for 1, not 4 1. Or the Y1 for the second.
Here?
Yeah, it's a 1.
Thank you for noticing that. Sorry.
It's 100.
Like that?
Yeah. That'll get different next time.
Oh, the XI will change? Oh,
The
okay.
X1. Yeah, XI, Y.
Oh, sure enough. Okay.
Hold on, mine's still weird.
So that's going to change my value here.
Yeah. Well, if you're adding up all of those, I squared.
The question is why didn't last semester students figure that out?
Well, you already said.
You guys are smarter than them, that's why? No, the real question is why did I make mistakes?
4.
Last 3 years, 4, 5, 7, 8. I just typed it in. There's no way I typed it in. Maybe you typed it in. Ooh, I did think of it. See, that's what you can't do. Yours, I can go back. It wasn't 200. I paid the same as you paid. Got it on sale.
I'm using my job and you just like to have any of the house that you know how much you $10.
Well, say never.
I started a program where I made swimming with my secrets as a kid.
Thanks for noticing that, Charlie. So that changes this.
3, 0.
3081?
Yeah, that's all I got.
Good. So then that changes here.
Did you see, when I was watching those math videos on multiplying by that, did you see when me and Steven racing in the math class to solve it? And he was crazy fast. He was doing like one way method. That math method, mental math. I was watching a YouTube video. It should be. That's the right hand. Some of the end one. So basically what he told me, that was useless. I would have been able to solve it with other person.
So, Andrew, what did you get for B1?
I didn't do B1.
Haven't got this yet?
I just noticed it just now.
Okay.
I was looking on
Charles, have you got B1 yet?
I got
0.377. Anybody else get that?
the. Yeah.
0.3773. The ironic thing, if you look at the data, it would, I think that it should have been 414 instead of 141. Because look, it's 278, then it goes to 557. What I should have done is I should have said, no, actually, we were going to go with 414. But this is good because it's going to give us a real outlier to show how the R square is all affected by that. That's fine. So 279.4. Yeah. Okay. So our cost, if this is the cost of a spacecraft, spacecraft cost is going to be cost is B naught, which is some fixed cost, 279.4 million, I think it is, plus, yeah, million, plus the weight of the spacecraft, x, times 0.3773. And so each additional, we don't have the units of weight here, I think it's pound. For each additional pound of the spacecraft, then it's another $0.37 million. Pretty tedious, right? I'm glad that you found it tedious because you'll just be really overjoyed when Excel does it easily. Let's take a break. Let's take a quick break to get a drink of water and stretch our legs. And then when we get together, we'll fire up the tablets and do this on Excel.
That's all we did.
Hey,
All right, this one's such a useful function to know. You can't copy and paste the data like I can. You're going to have to manually key it in. Some people think about what album they take with them if they're stuck on a desert island. I think about what software I take with me. And Excel is the software I take with me on a desert island. I'm just hoping the desert island also has a computer that I can use the software on.
Electricity to.
Yeah, solar power. Huh?
What about add-ons?
Add-ons, yeah. Probably the solver add-on. What add-on would you take on the desert island? Very good. Okay, so just get it typed in like I've got it there. And we'll make a graph. Seth, you doing this?
Uh-huh.
Okay.
Days like this, oh, you're in the same boat as me. No keep I wish I knew the shortcuts on that. I'm sure there is.
You want both R and the equation displayed?
What?
You want both R and the other one displayed?
We want the r squared and we want the equation. Yeah.
Had a little practice.
Okay, what we're doing right now is we've actually already started working on today's in-class exercise. So let me hand that paper to you that has some of the follow-up questions as we are building our regression model. Yeah. Here we go.
What are the red ones? You want it linear? And then what are the ones on?
You got that data typed in? Okay, so insert chart. I'll be doing it on screen here. Insert.
The red is also.
We want a scatter chart. Just with the data points is fine. We don't want also a trend line put in. So insert scatter of this kind, only with markers. Select data.
That's what
turn it where it automatically picks the stuff on there?
How do you turn that on?
Well, no, turn, because mine, like, whenever I go make a graph, it automatically just compiles everything and throws a graph at you, and then I have to go back
Yeah.
and remove things.
I don't know how to disable that.
What are you talking about?
How it automatically, it's probably an option.
Just highlight both of those. Just like on the data ranges.
And then make graph.
Yeah. Select data. Okay. Then insert graph. Insert scatter first one. Yeah.
And then, that's it?
And then you right click on the dots or whatever and chain line.
Okay, before you actually do the trend line, put in labels so we know what we're talking about on each of these labels. So X is weight in pounds. And here on the y-axis is cost in millions. The X values, you don't need to click that. I've got a mouse if you want one. Use the mouse, it'll be a lot easier. So the X data is just here.
What's this series?
So, select data, and you see the X and the Y.
Is that what you got?
Yeah, excellent. Already got your model. How did it fit what we calculated by hand?
Not too well, but
Not good?
there's our.
We should have calculated the same thing. Oh yeah, we can throw it shorter time.
Well, I thought you were talking about how it fit up.
Oh, yeah, I meant the
Yeah.
Well, that's good.
I think I'm really long.
Got it?
Yeah, change the.
Yeah, but there is that outlier there. Should have been 414, but I had it wrong on the screen, so. Where are you at?
I'm looking
Change
at
the chart type.
It's saying 122.
What did you do? Not better. And to put in labels, you go to layout. Yeah.
Is that not right? Or is that right? Same number over here.
I'm wondering if you switched X and Y. Look at the source data. Select that. Right click, select that.
Reduce the series.
You want to add an X?
See, I told you.
Oh, yeah.
That's each, that's your X value.
I know that.
Data different?
That's just the thing I got.
Where's X to be?
I know that.
Hit the backspace.
We can simulate what we did by hand this way and see if there were any errors along
I had
the
to
way.
move some of my.
X.
Oh, I didn't.
You see the change your axis.
X squared.
See, I just like that, not chart, make it smaller.
Squared.
I wish they
I
had
missed
that.
it.
See, if you're not reading the last 200, that I changed that to 1200.
Squared.
1200, yeah, read it.
Let me switch back to our notes. There's an error in the hand calculations on the board because we were supposed to do n times x squared. That's sum of x. And so here's sum of x. Sum of x was the B1. Oh, no. The sum of x squared. Sum of the x squared. Oh, this was the sum of the x squared. Oh, okay. That's not a mistake. I'm trying to find why it's different than what we've done before.
Can't trust me.
Then read that now. I'll have to search for trim bond. And I click on it.
What?
When you turn on, I click map. And there should be a format trim on. The third button, I didn't check display or.
No, this is not sharp. Oh, this is later. I didn't get one. Oh, you gave me. Oh, I remember.
It might be off there, so it's basically this
Yeah, it's touchscreen.
If I remember correctly, internet never worked.
On the board, we had 3529, on here it's 3256.
Okay. Oh, it's because of this thing again. 3256. So 3256, and then it's going to be a 81. So when this value, I had originally written it down as 414 instead of 141, and so it changed the xi, yi, and then it also changed the sum at the bottom.
So it would change your B of O also.
Pardon me?
It would change your B of O also. I wouldn't change the number.
Yeah,
You gotta plug that
because,
in the.
yes, because that's based on this factor 8134. Okay. So when we do that, we'll get that 1, and then E naught,
You're not gonna ask us to work this out on hand or midterm, would you?
not by hand, but I would maybe ask you to do it on Excel.
I can handle
That's pretty neat.
You know, like the way that we're doing it here. Sum-wise,
You would do like Pearson, you have to explain it on paper.
so
I think we can.
Yeah, type, what command would you put in at this point?
At this point in the scratch order, what would be your next logical step?
Blink out, I don't
I guess. That'd be lame. Depending on what that. It was either 2 or 3, 5 by 2 or divide by 3. That doesn't
I
matter.
don't know, I gotta be in the class. I talked to Shane the other day, he failed Pearson's class.
How do you feel here?
I don't know, he said he went into the final with a 80, I said he had to, I told him he needed to go talk to Pearson about it.
There's no way.
He said he got a D, not failed it, but he got that. He failed calculus.
Did you see him?
No, I texted him, see what he did, how he did on the grade.
I don't want to be here for what the others.
What?
Just like Roger.
Roger? Oh, Roger went off. I don't know what happened. Oh, yeah.
We might not have to do this.
So,
All on that one.
So I think it all finally matches. The manual method matches the automatic regression.
Okay, I have an Excel question. I know some that, one second, like when you type in, let's say you type in all kinds of stuff, and it like runs over into other cells.
Yeah.
Like, how do you, instead of like manually doing this, is there like a fast way of doing it?
You can highlight it, double click.
Oh, that's it? Oh, okay.
Oh, that part you don't necessarily got to do, but right click on that. I'll use add trend line, and then options, intercept and equation. No, equation and R-squared.
Oh, okay.
And now you've got that equation.
I'm really surprised I got a B in there.
I am too.
I went to the final with an A.
I went to the final with a 96, and then I ended up with a
Well, I had a low A, I was a 93.
I'm not gonna argue with it. And it might bring me to.
All right, so the last thing we're going to do today is on the second part of that in-class exercise, I'd like you to go online and get your own data for solar panels. Go to Amazon.com, type in solar panel, and see what you get. We want a spread of data to try and predict the cost of a solar panel based on its capacity. And we're interested to see how linear the data is for predicting cost as a function of capacity. Hopefully, that should be the main factor that dominates how expensive solar panel is how much power generation capacity it has. If you're using the tablet, remember to get wireless, and you've got to log in at the bottom. Is it seeing the networks?
This one's not being targeted.
Let's see, I'm not sure even which one means on. Let's see some of these other ones. On is forward. Is it pushed forward? Okay. There it is. Good. All right. So maybe Wi-Fi. So go on Amazon and find maybe a minimum of, what do I say in the exercise there, 5 or 6? 6 data points for price versus capacity. And try and spread it out. You know, don't have like 5 watts, 6 watts, 7 watts. Try and get a big range in data.
Just have two different. It's actually probably better because you can book, you just set it up.
What's the name of this one? Huh? What was the what of it? The very long beam. I thought it was that. Oh, you don't have the notes in front of you for the formula. Here's the formula.
So want this on the same spreadsheet?
Yeah. You can do it on a different page, like on sheet 2. I'm not going to actually collect these. I just want to take a look at it before you go.
Do you still want us to do B and C on the first part?
If we've got time.
So we're just comparing, we just need to get comparisons of wattage and.
Wattage and price.
That's pretty easy.
How about you would put in you just type it in like you would here, just digit.
Yeah.
Just push all.
Yeah, so what I said is like when I was calculating, exactly. And I was just actually, in the end, you used the sums, and so below that I did equal sum of everything above it. And then the equation is always referring to the sums of different columns.
Now what about do I not want to have two with the same wattage, different prices?
You could.
Are we trying to make linear?
No, don't try and make the data anything. Just, get 6 or 8 random data, and let's see what it actually is.
Leave it up to bed.
Huh? If you are selective in picking the data, but that's not what you want to do. I've recently made models of what a car should cost, a regression model based on how many miles it's been driven and its age. So, you can go on to cars.com and get lots of price data. If you've got a 2005 that's costing $10,000 and a 2008 that's costing $12,000, you can find out what the market is saying each additional year in age should reduce the price by. This is a similar thing. Gathering data. All right, now put it on a spreadsheet.
But how many should we get? Like 5?
Well, I think 6 is what it says on the page there.
Oh, I guess that's
If you that or more, the more data, the better.
as usual. I should read the question.
I just found
If you're doing divide by, you get parentheses around it, or just divide by the
What does this mean when it says buy new at 99 and then 5 new for $84? That makes no sense.
I saw that.
Yeah, that means that like some individual is selling it and they're saying that the condition is new, but it's not like one of their actual stores. It's like a little bit like eBay.
I got you.
One other thing too that's good is how to put titles on. So if you click the format, access titles. Yes.
Yeah, I never did.
Well, everything in the denominator. Otherwise, it will just divide by age, something around that. So yeah, so starting at.
I know what you mean.
And then.
Because you can get, like I got Microsoft Word.
Get closer.
They have it on my pages, but then on my iPad, I'll never use it.
Let's see this. So this is the one where you're doing so and
You don't want to use that.
also put it as project, but the C9 and the A8. Like enclose all of it. it's going to be divided just by, yeah, because the order of operations it does multiply and divide,
I don't
or
think
does the minus.
it's disgusting. I mean, no, it's not too bad.
Have you ever been over to Harbor Freight and seen the solar power setup they've got there? So you could know if that's a good deal by making a model like you're putting together right now that says price as a function of how many watts capacity it is. That kit they've got at Harbor Freight also includes a little inverter and I think maybe the charge controller. So it wouldn't be a perfect comparison since they're giving you a little bit more equipment, but it'd give you a rough idea anyhow.
All right.
Like a boss.
So
Would you pick the one, like, the great?
Yeah.
Okay, between all these, all right, if you want, like, best choice for efficiency, would you pick the one closest to the trend line?
If you want what?
Like, efficiency, I mean.
You have to plug that in.
Efficiency.
I mean, like, best, best wattage per price, or more, which one? Would you pick
Well, you wouldn't, that wouldn't, this wouldn't answer that question unless you see that there's something that has lots, something above the line has more than average watts per dollar.
Okay.
Something below the line has less than average watts per dollar. And so that's how you'd be able to judge.
So like that one right there would be.
That's a good deal. The further away it is from the line, the better deal it is. Above the line, above the line.
That's just more bang.
More bang for the buck. Right, exactly.
So that's it. So
How much
60 watts at
efficiency
270.
vary in solar panels, brands?
I don't think a lot. Like, but in terms of how much light shines on it to how much electricity it generates, I don't think that there's a huge variation.
So we didn't pay like a lot more money for.
Maybe it'll last longer.
You're saying the one at Harbor Freight's not gonna last
It's a
long?
better name.
I didn't say that. I would never claim such a thing about Harbor Freight School.
Harbor Freight schools. I had a Dremel tool thing that got them at literally when I was for the wind turbine.
Yeah.
And I was using it and it lasted 20 minutes and I had to like the Harbor Freight.
Were you gonna Roger?
I used it online.
There you go. Any Wi-Fi is the one you want.
No.
Or who else? Someone was playing a practical joke and disabled the Wi-Fi.
Remember, I did all the Excel that time too.
What?
I did all the Excel that time too.
Yeah, but I did all the.
All right, so since you're done, why don't you answer B and C on that first one? Really?
Sweet stuff.
Or for purposes to figure out how to get his line or
Nothing coming over here, guys. So you can test your data already. Price. What is this cost? Oh, no. That's that. It's got lots of price. In this case, it's
Kilowatts, it's 1,000 watts, right? Converted. 3,000. No, it's 0.3.
So you're working on question B.
Is there a way to take that off of the graph, the equation, and put it into cell?
You can highlight it, Control C,
Yeah, there you go.
and Control V.
Thanks.
Have you shown this is a map?
Here's something that maybe is good for you to know. Occasionally, if you're working with data that is really, really small, then you wouldn't be able to see the coefficient in front of the x. Let me construct an example of that. Let me save this before I do that.
What is the difference?
It's 96 points. I think this is Did you mean to put kilowatts on the
Yeah,
question? Say it to convert it to watts?
there's 1,000 watts in a kilowatt. Yeah, you did. 3,000 watts would be enough. What's that?
Yeah, but some engineers, we're not all engineering students here, just FYI.
Changed like 2 months ago.
You were.
You were about 2 months ago.
And did you know this is a magnet?
Did you know that that's frying that computer right now?
It was fried on my phone, dude. It fried my phone.
Why is that number so? That doesn't seem right.
You can't see that. It's cost.
So let's say you were working with data that was really, really big on one axis, and so that your slope, you couldn't see all of your slope, not to enough decimals. A way to get around that is you can have it, if you format the label, you can pick how many digits of precision to make it show. So like 8 or something, I bet we'll see. Now we can see that it's 0.698 instead of just, it was saying 7, and we weren't able to see actually more precision of the slope. So if you right click on something, format, trend line, label, it was this number category. And the same thing on what we just worked. If you don't want to see all of those digits there, you can, if it's getting too distracting, decrease the number of digits that are being shown here with these buttons, this little macro here.
How many digits will it maximum?
Will it what?
What's the maximum number of digits it'll show?
I don't know, unlimited I bet. But it doesn't actually, like, it doesn't take away the precision. All that precision is still there. If you're going to do a calculation based on it, it's not like it's actually rounding it off, it's just how many it displays.
Well, I don't know. It's not a calculator usually goes to what, 13 digits and done?
Let's see how many it'll do.
Well, I'm sure it'll go for that one. There, it does.
Yeah.
Mine was 16.
Was it 16? Right. So then it goes to 0.
Well, I think it'll keep going. It's just that the data itself doesn't have any more change based
I
on
got you.
I was gonna say pi.
Yeah, pi.
Expand.
Oh, well, maybe not.
You-
Huh. Interesting. 1, 2, 3, 4, 5, 6, 13, 14.
Our calculators will do more than that. We'll do one more than that. And that's 15, right?
Yeah, mine goes to
I think mine goes to 16 also.
So what sort of data did you find online? How much is a watt of capacity on Amazon? What is the cost per watt? Andrew?
It's 1.43.
$1.43 per watt?
I guess that's what that means.
So if you've got a graph that says watts, well, actually, what did you generally, how did you format your graphs? Did you have, we want to say, if you're willing to spend a certain amount, how many watts can you get?
Yeah.
All right.
I got like $9.
So the slope of the line is going to be the change in watts divided by the change in money. So if you want to know dollars per watt, it's going to be the inverse of your slope. All right, so then you're saying $1.49. So if we spent, if we wanted 100 watts, we got to spend 140. It would be, oh, plus 75. Okay. Yeah. All right. So. Plus 75?
Yeah.
So what are some of the other, what's your model say? Did you get the data on Amazon?
Yeah. I'm confused. What do you
57 cents.
I want to know how many dollars per watt. And so if you've got power here and cost there, so that's going to mean the slope of the line is
Well, my dad is different.
cost dollars per watt.
See, it's just weird because
You're
ours is
saying
like
251 per
Well,
watt.
the first time I did the
So if we
graph,
wanted 100 watts of power, it would cost us $270. Yeah, okay, so 250 a watt plus 35.
Yeah.
All right. 250 per watt plus 35. And what was the R squared of yours, Charles?
R squared was 0.90.
0.90. That's good, actually. That's pretty tight. What was yours? 88. R squared is 0.88. What would make this even easier to think of is if you forced it to go through the 0 point. Because, you know, like, what is this plus 75, plus 35? That's all of the variance that the model doesn't account for, the intercept. So there's something you can do if you right-click on your trend line and you format it. There's this set intercept equal to 0, 0. Turn that on, and it will change your equation. So it's going to eliminate this plus 75 and plus 35. Like if we're saying that we want it to assume that if there's 0 watts, it's going to cost $0. So we want an even simpler model. Our R squared won't be as good as it was before, but the model will be a little bit simpler. And so Charles, in your case, it changes it to 1.88, $1.88 per watt. $1.88 per watt.
What was your price on your?
Element, how about yours when you do that? You're saying 100 watts, which costs us 200 and some, so it's 248 a watt.
What the hell's going on?
248 per watt.
I think it's the.
Evan, how about yours?
I have 39 cents.
39 cents a watt? As the slope of the line? It might be that we need to do the inverse of that. Did you have it tell you the slope already? So you got your data watt price. What we're saying is that it's 289, like 285. That's what we're saying is price. And if you do that, let's make that equation a little bit bigger. So we're getting there. Now it's going to be the inverse. Still slight beta. One over that.
That's what I'm saying. It's screwed. What? It depends on which one you pick.
Right. So if we want to know how much 100 watts is going to cost, $200 or so.
I want that either.
So if we want to know how many dollars are watt, you got to set that on watts. Right. So you get 0.49 0.45 more.
I just pick one.
We're going to ask the other question.
It'd just be the inverse of that.
And I want
So
to
here,
add trend line. And I want to do display equation, do this, right?
Yep.
Then I want to set it equal to 0.
Sure.
Change it. It doesn't even have a.
do the best with line, right click on it.
No, it doesn't have the.
And set intercept equal to 0.
Oh, because it's 0.
Display equation on chart
I
y
got
equals
you.
squared.
So you don't want, you might be 0.
So now what's that saying? What you want is 100 watts, you have to pay 300. So here, it's, the data you found suggests that it's $3.36.
Here's the problem is if you click on another one and you say add, why if you add, like, I did this on accident, but I picked a different point than the first original one I did. Alright, so I got, it added a trend line, but it's just because I picked a different.
Delete the other one.
Alright, so like, I got one trend line.
It should be the same trend line regardless of what you click
I
on.
had trend line, and then I'll set.
Okay. So what's your question?
I swear to God,
It was a different looking one. Probably on the other one, it wasn't set to intercept at 0. That's probably what the difference was. Was that one of them was set to intercept at 0 and the other it wasn't set that way. Okay, so we're running out of time. I'll stick around for a few minutes if you want to finish up, if you just didn't quite get through with something you were working on. I think that everybody did the in-class exercises, so I don't need to collect in-class exercise 5. I'll look over what you've given me for number 4 and I'll return that to you on Monday. Remember, on Monday you've got a homework assignment that you're going to submit. And any questions you want to ask before we go?
What are all those kids in the hallway we gotta fight through?
I think they're having the West Point Bridge competition today. So, yeah, get a couple of chairs and just roll the chair, you know, and then do child bowling, middle schooler bowling. See how many you can knock down. You get a point for... Hi, everyone. Just going to do a quick tutorial to go over some of the concepts that are presented in the linear regression model and then also illustrate how you can calculate the standard error. So you'll remember from last time what we did was constructed a manually found the best fit equation, and so we had a spacecraft where we knew the weight in pounds of the spacecraft and then how many millions of dollars, and there was, it looked like a relationship there between how much the spacecraft weigh and how much it cost to create it. And so to do it manually, we found the sum of x squared, and so we have to have each of the x terms squared, and we needed to have x times y for each of these. And we can just double click here, by the way, and that fills it in. Little tool there. This formula here of sum, just to show you again, what we're doing is we're going to need all of these in the formulas that we use that are shown just below. So it's the sum of everything above it. And then we can drag that sideways, and it applies the formula to all of the things above. Let me get the commas in there, make it a little bit easier to see. Alright, so now we've got the sum of the x's, the sum of the y, the sum of x squared, and the sum of xy. And so we're going to use those in calculating the B1 parameter. Alright, so the B1 was n, which is 6, times the sum of the xy's minus the sum of the x's times the sum of the y's. And we're going to have to put some parentheses around all of that, because if we don't, it'll do the order of operations wrong. So now we want is n, which is 6, times the sum of x squared minus the sum of x's squared. Alright, I think I've done that right. Let's just see. Yeah, Okay, it's a little bit confusing because on one term here you've got the sum of x squared, which is talking about the sum of the x squared, and then you've got the sum of the x's squared. So if you look at the formula, we've translated the B1 formula using all of those parameters. And so then now to calculate the B naught, we have the y's, sum of the y's, minus B1 times the sum of the x of I divided by n, which is 6. Alright, so now from that we've got the intercept and the slope. And the other way that we did it besides the manual approach was if we have a trend line, we can just select the x values that we want to have graphed and select the y values that we want to have graphed. And you can see that there's a scattered data there. Add trend line and display the equation and the r squared on the chart. And lo and behold, that matches up with what we had manually found. And so thus y is b1 times x minus the intercept b naught. So the graphical and the manual approach coincide. So in the second video I'm going to show you a little bit about standard error. In the tutorial you just saw, we created a linear regression model, 2 of them. They both had the same result. We use that to predict the expected cost of a spacecraft based on how heavy it is. So its cost as a function of weight. But how good is that model? One way to evaluate the goodness of that model is with an r squared, but an r squared is a little bit abstract. That doesn't necessarily tell you what sort of error you're going to see if you use that model to predict it, predict the values. And so standard error is a way of predicting in the same units that you're working with what sort of accuracy you can expect with your model. So let's say that we have the data here, the same data as original. We know the spacecraft weight in pounds, its actual cost. Well, what cost is predicted based on the regression model from before? So if we use this equation that we had before, let's type in and find out what the expected or predicted cost would be. So the cost is going to be 0.8134 times the weight minus 122.96. And so we're actually using that model now. And so, for example, a spacecraft that should weigh 400 pounds, the actual cost that we know based on the data we have is 278, but using our model would have guessed that it was going to cost 202. So for each of these predicted values, what we're doing is we're substituting in the weight into our function from before and finding out the predicted cost. So now, in this formula, to calculate the standard error, it says that we need to have this, the difference between the predicted and the actual cost. And so that's what I'm going to do in this column, equals the predicted minus the actual. All right, so we have, oh, I'm sorry. Well, it doesn't end up mattering because we're going to square it. You can see that here I've got actual minus predicted, and up here it's the reverse of that. Since we're squaring it, it doesn't matter which comes first. So we drag that down. And we know all of the actual minus predicted costs. Here, we're going to square that. All right. Oop, not there, though. Okay, so we've got the square of all these. And so this now says we want to take the sum of the squares. And so equals sum of all of these up here. All right. And now the standard error is the square root, SQRT, of the sum of the squares divided by n minus 2. N was 6, so n minus 2 is 4. All right, so what that means is that when we use this, we use this model with the data that we have, the average, or the standard error, the error that we can expect to see, is 109.64, the difference between actual and cost. Now, that's not the same thing as the average of these. It's a statistical measure of model quality that takes into account the size of each of the values. So that's the manual way of calculating the standard error, and you can do that on paper. You don't have to use Excel to do it. One of the advantages of using Excel, though, is it has functions that oftentimes can take some of the work out of your hands, and so that's the case with this formula here, STEYX. And so one of the nice things about Excel is when you start to use it, it'll prompt you for what data you should type in. So equals, and I'll demonstrate it, STEYX. And so as you type it in, you can see that it's telling you it returns the standard error of predicted Y value for each X in a regression. So when we put that in, it's going to prompt us the known Y's. And so Y values are what comes out of the model. That's the dependent variable. And what comes out of our model is the cost. And so it's for we put in the actual cost, the known Y's, so we highlight the known Y's, then we do comma. Now it wants to know the known X's. So the independent variable, what goes into our model, is the weight. So this is the range of the known X's, and that's all. When we close that out and press enter, what it's doing is it's first creating a regression model, and it's evaluating the standard error of that regression model. It's kind of interesting. In this function, it doesn't even need us to tell it where the predicted data is because it's doing that itself. Press enter, and you can see 109.64. So those are two different ways that you can calculate standard error.